a lot more, take a lot more lines of code, what they would be doing was working backwards. The Python version of this may be about this many lines of code, but it would be doing a lot more. The background because it's a higher level. For example, let's look at this line. This line could take a different number of computations based on the data structure the cipher is using. Maybe we store our data in a list, and we need to check each letter against our current letter to solve the code. That could be as many as 26 checks for each letter in our input string. So ultimately, our efficiency calculation might look a little more like this. Let's go back to those example input strings we talked about before. Now, if we start out with a 10-letter input string, we end up with 292 computations. If we start out with 1 million letters in our input string, we end up with 29 million steps to go through. Because of our choice of data structure, we're doing a lot more computations than we might if we chose it a little bit smarter. Later, we'll talk a little bit more about the efficiency of different types of data structures. But for now, hopefully you realize the importance of thinking about efficiency before writing code. Since the amount of steps can vary widely based on the specific implementations, we normally use approximations when talking about efficiency in Big O notation. Since the efficiency of the pseudocode we wrote before could end up looking like any of these and even more, we would say that the efficiency is actually about Big O of n. If you're writing code for production, you definitely care about the number of computations and want to minimize it. However, in an interview, your interviewer doesn't care that you can do that exactly, but just wants to know that you are thinking about efficiency and can calculate it if you need to. By approximating, we're really saying some number of computations must be performed for each letter in input. There's actually more things you should consider when using Big O notation. If you noticed before, I said you'll need at least 26 checks to get through every letter of the alphabet. In reality, it's unlikely that you'll have to go through all 26 letters each time. When we're discussing efficiency, we often talk about it in terms of the worst case scenario, where we would have to check all 26 letters each time. We focus on worst case because it puts an upper bound on the amount of time our code is going to take. You could also talk about efficiency in terms of the average case or even best case. So if we're talking about letters in the alphabet, the worst case means we would have to go through all 26 letters. However, the best case would be that we find what we're looking for on the very first try. But on average, we're going to fall somewhere in the middle, around 13. In a perfect world, iterating through a list of letters is going to take an average of 13 times. Sometimes it'll be a little more, sometimes it'll be a little less, but it's fair to say it'll be about 13. If we're going to try and calculate the average case efficiency, it's going to look a little more like this. In the end, we'll get 16n plus 2. Now let's go back to our point about approximation. If we consider the average case, the worst case, or the best case, it's all still going to result in Big O of n. In an interview, you might be tempted to combine the average case, the worst case, the best case, and just give an answer like this. However, the best case, the worst case, and the average case might not always approximate this nicely, so you really should specify to your interviewer which case you're talking about. We've been talking a lot about time efficiency, but you can actually use the same notation to refer to space efficiency too. For example, let's say you needed to copy over your input string 3 times in your code for some reason. Then the space efficiency would look something like this. Space efficiency is asked less frequently in interviews, but it's definitely something you should consider because it will come up from time to time.